I'm trying to reach my
Okay, so maybe some of the confusing things I can say something about, and then we can decide what our questions really are. So when they talk about real number division, let me give you an example. If we took 10 divided by 3, and you did that on a calculator, you get 3.3 repetend.
Yeah.
3.3 repeating. That's real number division. If I did it as integer division, oops, if I did 10 divided by 3, I would have 3 with a remainder of 1. You could write it that way, but you guys, you're big kids now, so you should know that that remainder is the numerator of the fraction. It's the only difference. That's what they're looking for. Yeah, I know, we should have skipped this lesson, because I don't want to get lost in this kind of stuff for what really matters. What really matters, the only takeaway from this lesson is this. When you do division like this and you have a remainder, the remainder is the part of the fraction. That's what I want you to see. So if I was to take 10 dots and arrange them into 3 rows, 1, 2, 3, 4, 5, 6. I'm just putting them into 3 rows. 7, 8, 9, and then there's that remainder. And that remainder is 1 out of 3. So I drew blank circles there because there's nothing there. So this is the third right here. 1, 2, 3. That's the 3 wholes. That's what we want you to be able to see. And you probably know that it's that way, but I want you to recognize it and realize it and know that it's not going to go away just because you're going on to higher and higher math. Because some of the old things that you'll learn when you're a little kid, this idea of remainders, become more and more important with your math as we get away from what you've been doing for the last 2 or 3 years. That's all. So with that, now ask me your questions. What do you have?
17 and 22.
Really?
20.
17, 20, and 22? I don't know. We're going to find out. Why 17?
I'm just kind of confused on it.
Am I in the right book? Is that solving for x?
Yeah.
Oh, that's a review problem.
Yeah.
Yeah, but
Good.
it's kind of weird. And it's going to fraction and
Oh. Oh. Well, let's look at this. See, remember I told you the other day that we did not do the lesson on inequalities.
Yeah.
And what I said is you act as though it's an equal sign. So you do it this time. So what would you do if this was an equal sign?
Well, that's the thing.
What would you do? You divide by 3 1/2.
But then you have to like.
That gets confusing, dividing by 3 1/2, doesn't it? Yeah, well, okay, so let's talk it through a little. So let's just write it like this first. Okay, now, is the answer positive or negative?
Negative.
Okay. And we're dividing by a negative, so we're going to change the direction of the inequality because everything's going to become its opposite. So this is going to be a negative answer. So now we just have to figure out what is 3 or 7/3 divided by 3 1/2, and that's going to be put after our negative sign. So you have a fraction, right? And then you have a decimal number. That's confusing. So we can either change the fraction to a decimal,
No.
or we can change the decimal to a fraction.
Yeah. Yes, and we'll do a fraction.
If we change this to a decimal, can anybody see what it would be?
That'd be like.
Like, maybe 2.3 repetitive.
2.3 repeating, and that you don't do real well with division of because it goes on forever. There's no estimating that is allowed. So then it would be better to change that to a fraction. So we'll write over here, 3.5 into a fraction.
3 1/2.
How should we start by rewriting this?
Multiply first. Yeah, multiply 3.
What's the
Simplify.
denominator
Well,
gonna be?
Isla, if you were gonna do this, if you had the number like 4, and you wrote the number 4 as a fraction, what could you do to it?
Put it up 1.
Put it over 1. So let's just do that with this. Let's start, and then look at it. It's not a real pretty fraction, is it?
Yeah.
Because it has a decimal point. So can you write an equivalent fraction that won't have a decimal point?
Well, yeah.
So, like if I wanted to write an equivalent fraction of this, I could multiply the top and the bottom by, the same number, right? They're still equal. 4 over 1 is equal to 8 over 2. So what could you do to this so that that decimal point goes away? 7 over 2. Because you multiply that number by 2, you multiply this number by 2, that's an equivalent fraction. Okay, so here we go. Now let's go down here. 7/3 divided by 7/2. Multiply by the reciprocal. And 2/3 because the 7's go away. See how pretty that turns out? As long as you stay away from decimal numbers. That's it right there, 2/3. So let's see if it makes sense. This is the cutoff for where all of your answers can be. All of your answers can be smaller than that number. So if we pictured this on a number line, all of our answers are going to be smaller than -2/3. So is 0 going to work? So go back here to the original problem. If you put 0 in there, it should be false. It's -3.5 times 0. 0. Is 0 greater than 7/3?
No.
No. So then we have the right set of answers. You could also say, well, I'm going to check -1. So you have -3.5 multiplied by -1. Is that greater than 7/3? Negative times a negative is positive, so that's 3.5. Is that bigger than 7/3?
Yes.
Yeah.
Because we said 7/3 somewhere was 2 1/3. So yeah, that works. Fine. Ooh. 22. 22, huh? 22 is the racetrack. That's like an oval. 20. Triangle QET has those coordinates. Its expansion, so it gets bigger, has these coordinates. What is the magnitude of the size change? So let me ask you. Going back to what you've seen written a whole bunch of times on the board. When we put our points in here, and then we rewrite what the new image will be, how have I shown you to enter this? It's got to be parentheses, and there's going to be an X in here, there's going to be a Y in here, but what did I ask you to add in? And whatever you're multiplying this by to get this number. So there's going to be a magnitude, a number in here. So if we lay our work out like that, here's point Q, and this will be point Q prime. Q is -3, 5.7, is that correct?
Yeah.
And then Q prime is 4, -7, 7.6. Is that right?
Yes.
Okay. So we could put all of them in here, I guess. Let's put E in. I'm not gonna put them all in, but I'll put 2 of them in. Is that correct? And then E prime. Is that correct? Okay. So the idea here is that when we have a magnitude of size change, we're multiplying the x's and the y's by something to get new values. So we have to say that this number multiplied by something will be equal to that number. So this -3 gets multiplied by a number that we don't know what it is. So let's call it, what, A? Yeah, I don't want to call it X, we get really confused. And that's going to equal 4. So we have to figure out the number that we multiply -3 by to turn it into a 4. What is it? It's got to be a negative number. How do you find the solution to this? Yeah, divide by -3. So A is going to be, and you would write that -4/3. So A is a -4/3, which is the same as a -1.3 repeating, but you don't want to do that because you can't put that into the calculator. You can't multiply it by hand. So you either leave it like this, or you write it as a mixed number. Leave it like that, it'll be easier, I think. Now, yeah, here they go and they change all this stuff into decimals in the book, but I think it works. 0 times that is 0, that's good. That works. You can check those actually with a calculator. If you multiply, you can enter -4/3 on your calculator. And then you can multiply each of these numbers. I'm sorry? How do you put a fraction in the calculator? Yeah, grab them, do it. I'll talk you through. There's several ways. The easiest way is to probably just put in parentheses your fractions. So let's see if 5.7 multiplied by -4/3 is equal to this. Yeah, here, I'll write a key sequence up here on the board for you. So if we want to take 5.7, enter that, and then times, and then you need to use the negative in parentheses. And then you want to use your parenthesis, 4 divided by 3, and then the right-hand parenthesis, and then I think you can hit equals. And it's going to spit out a decimal number. Yeah, -7.6. Okay, once you have -7.6 on there, go to math, I think. Does the first one say fraction dec or something? Just hit enter. And enter again. And then it just changed it into a fraction.
-38/5.
Yeah, 38/5. 7/5. So now you hit math on the far left underneath the alpha key. Math. And then it says fraction. So hit enter twice. And it changes that -7/5 into -38/5. Which is the same as this. So you can go back and forth between fractions and decimals with these things.
So that'll keep everything in a fraction?
So arrow up to negative, now hit enter, and now hit math. And now hit enter again. You've got a new key sequence. Anything else? So yeah, they do a lot for you. But you still want to be able to do a lot of this in your head because it takes time. But it's possible to be done. And there are situations where we do this with like lots and lots of numbers at one time. And we work with like something called matrices, which are pretty cool. We'll do those next year. Okay, so that's 20. Can I go from there? What about what? What about 19? I've got 22 written up here, yeah? What about 19? What is 19 asking us? 500-year storm. I think that's what the storm was that caused the disaster last fall, early winter. They called that a 500-year storm. Its chance of happening was 1 in 500.
Only?
So what's the probability that it will not occur next year?
499.
It's the same thing, it's the complement, so it'd be 499 over 500. And the probability that it would occur 3 years in a row. So 1 year does not determine the probability of the next year. So for example, what we had for a storm end of November that caused the disaster and everything in the borough in southeast Alaska, the probability of that happening next year is no different than it was this year. Just because it happened doesn't mean it's not going to happen for 500 years. That's not what they mean by this. They mean that each and every year there's a 1 in 500 chance of experiencing a storm like that. It's not likely. Could it?
It could.
You bet it could, but it's not likely. So to find that probability, how would we go about it?
500 times 500 times 500.
1 over
Or
500.
1 over 500.
Yeah, to the third power. Which is a, so you have 5 times 5 times 5,
125.
246. 1 in 125 million. But that doesn't mean that it can't happen.
Yeah, it's just very, very, very unlikely.
It's just not likely. Things happen. My son Murphy, when he was a little kid, was pushing on a door with his brother and his cousin. And his cousin was holding the door. And Murphy was holding the door. His cousin, who's bigger than him, was pushing. And then his cousin stopped pushing. So he took his hand off of the door, right when his cousin just went wide open. The door went flying, hit him right here. Laid him wide open, right down through his eyebrow. You know, I mean, we're talking ER on the weekend. It was a bummer. They sewed him all up. A year later, Murphy's chasing his little brother through the house. And his little brother goes through a doorway and holds the door behind him, and Murphy comes as the door is swinging. Wham! Literally on the scar. This time his skull was sticking out.
Whoa.
So what's the probability of him hitting that exact scar? I don't think it's real high. He has a single scar from 2 pretty good door injuries. Same door.
That is just
An unlucky door.
It was funny.
I don't think it was funny for him.
Yeah, no, probably
Not
not.
then, it is now. That was a long time ago. Okay, so 22. So a racetrack is shaped like an oval, like ours, except this one's bigger.
Okay.
Well, yeah, it's 75/100ths of a mile,
Yeah, it's a very big
3/4 of a mile on the straightaways.
Ah.
And then it's a semicircle that has a radius, we don't know. But we know the perimeter is 3 miles. So let's do this. Yeah. This is 0.75 miles. And then there's a radius. But see that, there's an imaginary circle. our track is drawn or is made exactly the same way. There's an imaginary radius that's used to make that track. And the radius, if you went to the beginning of the curve, that radius is halfway between where the straightaways end. That's how they draw tracks out. So anyway, this is 0.75. And the whole perimeter is how far? 3 miles. So, yeah, if you found the circumference of that imaginary circle, see this over here is this half, so let's just draw that in, and let's turn this into dashes. Let's move the radius over here. So you have 0.75, 0.75. How much is left for distance? If the perimeter is the distance all the way around the track, what's 0.75 plus 0.75? 1.5. So the whole circle has to be 1.5. See, this would be 0.75 and that would be 0.75. So the circumference of this circle is equal to 1.5 miles. And what is the formula for the circumference of a circle? Oh, I bet you saw that the other day. Whether you knew it or not, it had to be in that test. There's a lot of geometry in there. It wasn't in there?
Yeah,
Oh,
not
a
many.
lot of square roots this year, huh?
Like a lot.
Like a lot.
Like a lot, the entire test was square roots.
The whole test was square roots this year, huh?
Like, hello. Normal, please. And it's like,
Okay. So, what's the circumference of a circle?
Isn't it like
360. Wait,
That's
Yeah.
degrees.
yes, degrees?
Circumference of a circle.
Smart.
Pi r squared is the area. Every time you deal with something that's round, pi is involved.
Yeah.
So pi is gonna be in there,
Pinds are right.
but it's not r squared. R squared would make your units squared, which would make it area.
Isn't it
It's
3
just pi
point?
times diameter.
Yeah.
Okay, so here's what we have to do. We have to solve for the diameter and then cut it in half. So you would solve this just like you solved this. Pi times diameter, so you have to divide both sides by pi. The diameter is equal to 1.5 divided by pi. But you don't want to do this yet. And then you have to have half of that because 2 radii make a diameter. So you got to take half of this. So you could take that and multiply it by a half. So it's just 1.5 divided by 2 pi on the calculator. Probably comes out to about 1/4 roughly. So this is about 1/4 of a mile across. That's about what you would have gotten. Okay, are we done then? Does that do it? Ready to talk? Any bananas in there?
Oh, yeah.
I got 52.14.
Question mark. I just did it on the board, dude.
Right, how many
You write that in, you choose.
Okay, number 10.
One thing I'd like
Number
you guys
10?
to work on getting in the habit of doing is when you do not know how to do a particular problem and you watch me do it up here,
What did I get?
you should take the time to put that in your notes.
I got
If I see that
52
you
with
don't
the
do that, then
remainder
there's no
of
point in
1.
you doing it.
Yeah.
Your notebook is going to be a reference for you for quizzes and studying for tests. Think of it that way. The racetrack one. So, another thing is if you have your book open to the homework assignment, and then I just write number 22 up there, you can go, oh yeah, that's that problem. And you look down at it. But if you're just gonna sit and watch me like you're at a movie theater or watching a television program, where you're just sitting back and like taking it all in. We're better off spending our time doing something else. You're aware next year we're gonna go 5 days a week, right?
What? Wait, that's what we do now.
Yeah, that's what we do now.
No, I'm talking algebra will be 5 days a week.
Oh, I thought you were talking about
Yeah,
school.
and it will be a little bit different look. It will be a faster pace, especially with the fact that it's 5 days a week. You know, this year and last year, you would always get Thursday, kind of recovering everything. But it's gonna be different next year. It's a faster moving class. Being organized with your notebooks is gonna be a huge plus. Knowing what you're looking at on the board, what I'm doing, will be a huge plus. We'll be in a whole lot better environment. We're gonna be in a smaller room. We'll be up closer to one another. It'll be easier to engage. And we'll have a bigger smart board. Like this big.
Big.
Bigger than this. And, so you feel like you're in a rock and roll show. But it'll be very fast moving.
We don't really use the smart board in here.
No, we don't, because it doesn't work very well at all.
Oh.
So,
We don't even get them.
what's that?
We don't even get them.
We got 3 new boards yesterday. Everything's gonna have boards next year. Yeah, we get boards going in places that they haven't been before.
So that's expensive.
Yeah, they're expensive. Yeah, they're not bad. $2.5 grand a piece. Considering how big
Would you
they
rather buy
are
that
and what
or
they
a brand new
do, they
gaming
have a
computer?
computer in them and everything. I think they're actually pretty
It's just
fair
like a really
price.
big monitor, though. It's literally just a big touchscreen
Yeah,
monitor.
Yeah, that's how big the smart boards are that we got.
Yeah, exactly. It's touchscreen.
They're huge.
I'd
Yes, sir.
rather get a gaming computer. Get to tell my
I don't know, it's like 6 feet.
You can only use a monitor if you have
So
a
it's a little
working
bit bigger than
computer.
that. The boards are bigger than that.
hard talk.
Okay.
Hey,
Um,
just ask how tall you.
All right, so I'm gonna erase that since you've had time to write it down now.
Thank you.
Okay.
Wait,
So,
where would they fit them?
I don't know, we're still trying to figure that all out. It took 3 of us to carry them in yesterday, that was bad enough.
Are they
Yeah,
that
Mr.
big?
Baumgartner and I went to lift one up and we bent over, we went to lift it, and just like it didn't move, and we just looked at each other, and said, oh. They're really heavy. Okay, so division, we're gonna stick with the division a little bit. And one of the things that you are going to see more and more as you get into science in the high school is that when you are solving problems in science, the expectation for showing your work and setting up your work is gonna be different. It's gonna be more like what I've been asking you guys to do. And a big thing that's gonna show up in the calculations that you do and the work that you represent on paper is that you show units. Because when we set up problems and we solve problems, if we put the units in the right place to start with, where they end up in your answer is gonna tell you whether or not you did the work correctly or not. It's very, very helpful. It's not just like this random number, well, that's what it was on the calculator. That's not gonna be real productive. So setting up problems is important. So, here's what you need. You need 9-2. That's all I want you to write in your notebook right now, and today's date is the 23rd. This is gonna bleed into Monday. And then you can close your book. I don't want you to be looking in your book. And I want you to take your pencil in your hand, in your notebook. And I want you to do this. See the second hand up here? Tick, tick, tick. Here's what you're gonna do. You think this through. You're gonna look at it, and when it gets to a particular number, I want you to neatly write your name, print it out, print it letter by letter by letter, and then look up and see how long it took you to do it. And then write down to the nearest second how long it took you to do that next to your last name. So do your last name first.
Can you pass around his limit or is it?
No, hold on. You're writing your last name,
Oh, my last.
you're printing it out, you're gonna time how long it takes to do that. Neatly, just neatly, not like art perfect, but readable neat. So it's not a race to see, oh, see, I did it, oh, really, that's my name, no, not. I wanna be able to read it. So, I'll give you 15, 20 seconds to get that taken care of, go. No, just your last name. And then once you're done, write down how long it took to do that, right next to your name.
No,
And then when you're done, set down your pencil so I know you're done.
Technically, 4 seconds for estimate. But also, like, it could be wrong to me because I feel like.
The question is, can you read it? Yeah.
Can you read that? Is it nice and readable?
Yeah, it looks great.
I think the person who are in nowadays.
Okay, now, listen carefully. Switch hands and do the same thing with your first name. Yeah, switch hands, do the same thing with your first name, or with your first name.
You're not gonna be able to read this.
I wanna be able to read it.
Can you read that?
Oh, I made it the wrong
Oh, eyelash. Oh, geez.
So difficult. Yo, Emma, yours is real hard too. Oh, wow. Huh.
He spelled your name wrong.
Yeah.
It took me 14 seconds to write my first name.
Emma with one M.
Do you have lip on the back of that letter? I don't know if you know. There's like a sheet.
I know you're reading
Emo.
Okay, now you have two calculations to do.
Wait, Mr. Dagan, can you read that? Is that?
Yeah, I can read that. Okay, so,
My left hand looks like your handwriting.
Yeah, no, that just looks like my normal handwriting.
Right. It looks like somebody was like shaking the.
Miranda, Dalton, Hayden, you guys set? Dalton, you guys set? Okay, so we have number of letters, and we have time in seconds. So we have two different units. And when we combine two different units together, we call that a rate. So we could either look at this rate as seconds per letter, or letters per second. Which do you prefer?
Letters per second.
Yeah, I like letters per second. So I'd like you to figure out how many letters per second
So we would divide it.
you did for left hand and for your right hand, for your dominant and for your recessive hand. So you may use your calculator to do this calculations, I'm not sure. Let's see.
Mine were actually really easy.
Mine too.
Orion, Karen.
That's easy.
No, oh, it's 13 letters, but the calculation is easy because I got 7 seconds for one.
Oh, I got 2 letters per second.
So I got 13 letters per second and 5 letters per second.
Divides by 10. I got 1.4.
I got 13 and 5. 13 letters a second? That seems wrong.
Wait, how are you supposed to do that again? Letters divided by.
Wait.
I think it's seconds divided by letters.
Wait, if it's letter, divided by seconds. In 7 seconds. No, I did it wrong. Okay.
I got the same count, I think.
It's just
13.
Smith and Jack.
Yeah, I got 1.25 and
No, you might
1.25.
get, this is like concerning you.
I got 1.4 for my
How
first one.
long is it required to compose yourself under an egg?
What do you get?
I don't know. I'm doing it.
Okay, so here's, you guys have your numbers figured out?
The exact mix.
No, my hand?
But what if you do 25 letters? That's not right. I know it is right. 25 letters a second, that's not right. If I do.
Ariel, dang. 25 letters a second?
They're all happening.
Faster.
How did you manage that?
They're all happening.
My last name in 1 second.
Is it dinner before?
Isn't it Bell?
Yeah.
So do you have your numbers? You good with them? Are you good? Are you guys both good with your
Yeah,
numbers?
what you get?
How about you?
I got
Last name.
5.
How about here?
I'm doing. I don't have my calculator up in my.
Oh, okay. You good? You have yours? For both?
For both.
For both?
Yep.
Well, you're a baseball player too. You have yours?
No.
I don't know why, but I was
10
faster.
letters in 5 seconds.
I was too. The problem is, my left hand, I'm really good with right hand, just my left hand's very shaky.
Divided by the number of seconds.
2 letters for a whole second.
When I was younger, both my hands used to shake, it was horrible.
You like good?
I had shaky hands.
Yeah.
And then there was.
You're good?
My left hand shakes.
Does that make sense? Yeah.
Yeah. Clover? Did you take the number of letters divided by the number of seconds?
Ryan, what do you draw?
No, I'm doing math.
That quick?
So short.
That was short.
Yeah, it's a Friday.
That's what I would say.
Friday's all possible.
What do you mean by baseball player?
Well,